Today we are going to look into layer thickness in the furnaces, how it helps, how it affects the aerodynamic behavior of the blast furnace, and how the production and productivity depend on it, and what sort of a strategy we need to adopt to optimize it. Now question arises that when we charge coke and ore, it is not only influence gas flow, permeability, reduction, but also dictate the burden stability and overall furnace health also, because this also decides that what sort of load distribution, that is thermal load getting distributed across the vertical height of the furnace, and what is being specified as a heat load boundary for each segment. And once the operator follow this, then our campaign of the blast furnace gets extended, which is supposed to be one of the most important objective of any furnace operators. So let's decode the science behind smarter layering, about which we have already talked so much. Cooked as a act as a breathing passage for the gas is known to everyone, while wood drives the reduction. A thicker coke layer enhances permeability, and a thinner ore layer supports efficient heat transfer. It's not just a starting game, it's like a delicate balance between chemistry and physics. Now, before going further, we need to also understand the restriction, the challenges created by a mixed layer, which is very important because ideally each ferrous and non-ferrous, or we can say coke and non-coke, whatever terminology at different plants we have, these are to be segregated in the furnace in ideally layer where it almost should a stagnant layer across the throat of the furnace, and aiming something our central opening, which is supposed to be a ore free of not very huge bigger dia, so that if our annular opening, that is what we say center chimney, or many terminologies are there, if it's wide, then our utilization is also come down, our optics may go high, and so many things, and our fuel rate also go beyond our expectation. So we need to see these mixed layers, how is being planned by the blast furnace people, because once we uh, come to have a more quantity of mixed layer, uh, while while distributing, then we can say that this mixed layer hamper the uniform descent of burden, as well as it hindered the wind acceptance, and further it affect the productivity of the blast furnace. So now thick ore layer resists heat and slow down the reduction. As we know, thinner ore layer allow faster heating, quicker reaction, and smoother melting. So what is our goal then? So we have to keep ore layer thick, ore layer just thin enough to maximize performances. Now it is a much more vague line, maximize performance, and to the very specific, I want to mention that what it mean is that whatever ore is there, it need a indirect and direct reduction carbon, and whatever coke we are supplementing, its carbon value should supplement the ore layer to take care of direct and indirect reduction. So there is no one size fit all rule. So layer thickness depends on raw material type, charging precision, screening efficiency, and again one one very important parameter area is there, that is the PCI rates, because all furnaces are running with a good amount of PCI rates, and everyone try to evaluate the thermal profile, the descent rate, the production and productivity in with respect to maintaining a PCI rate of around 140 150, otherwise cost of production never become economical. So operator must adapt based on what being fed in the furnace each day and in what type is more important for them. Now, in the process, what happens that when operator try to pull down its coke rate to a optimum value, then it is really across the throat. There are some portion where these coke layer become very thinner, and in the process there is a always chance that ore on ore contact may takes place, and once this type of phenomena, one this type of pillar of ore form, it create a big problem for the furnace. So in this context, it is always required that operator should aim what should be that minimum coke rate he has to maintain across the throat or in the furnace. He should aim, and for that purpose, there is a, a rule of thumb or a sort of a yardstick which can just navigate that around this or below this we should not land, and we come across these, then we can say that to prevent ore on ore contact, we need a cushion at least 3 coke particle high, and that is basically roughly 15 centimeter, considering the size, or we can say 150 mm, considering the size of coke particle is 50 mm average, and as for the layer thickness at the throat is concerned, it must be around 34 centimeter. So that is our safety threshold to preserve gas pathways. Now, coke rate below 210 kg per ton hot metal are ideal, but often run higher over long campaigns. So operator need to know all such type of rule of thumb or a sort of a ready available information or a sort of a yardstick to catch hold of a easily visible mistakes in the furnace operation. Now, these also, while doing all these, optimizing the fuel rate, there is also chances of two-way tipping or burning of tuyers or copper coolers damage is many times becomes very obvious due to our abnormal distribution also. Hence, to avoid two-way trouble by maintaining coke near wall is a also very judicious decision. And in this type of decision, it is always advisable that we should not sacrifice our coke, which are basically very essential in the intermediate and central regions, and also it is to be a safeguard from the solution loss. So in this context, our nut coke becomes a very important material which need to be used in three aspects. One is it can take our solution loss reaction, so gasification can take care of this nut coke, and nut coke should consumed totally before coming to the hearth. These we have to ensure, and that much only nut coke is to be taken. Second thing, nut coke must is to be used in a wall area so that it can ease our cohesive zone, and where respiration by cohesive layers becomes much easier in presence of nut coke. compared to coke. And third is, once we nut coke sacrifice in the peripheral across the wall, which helps in taking care of lateral moistures and so many things, is also safeguarding loss of our core coke. So we can say that nut coke in ore layer helps us stabilize the burden and preserve the structure also. And 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 it also prevent layer contact, that what we have already discussed earlier, to reduce risk of gas bypass or skewed heating or tipping of tuyers. So this is a sort of a thumb rule where operator need to know that in the throat area we have to keep ore layer around 80 centimeter or below than this, and similarly coke layer should not be thinner than around 30 centimeter. So it is just a sort of a navigation where it alert us that if they find some abnormal calculation is coming, it is we can check with respect to this data. Also, the reject fines under 5 mm is a killer, and this also need to be evaluated in day-to-day working. Now, coarser ferrous material also ensure uniform descent and better gas contact, and for that these undersize items, undersize fractions is must to be eliminated from main course of burden. This is basically information to visualize the operator that with conveyor our ore tend to pile thicker, while skip charging offers a better control, historically used for coke, but with high PCI full ore skips are more common now. Here we try to utilize the full potential and higher productivity. So matching burden type with charging strategy is very important. So now coming to the coarser coke improvement and its effect on the flow, that how coarser coke improve the flow is very important, but at the same time it also generate more nut cokes, leading to the thicker mix layer. So a trade-off exists: balance coke sizing with the layering goals, and monitoring our permeability change very carefully. So we can say that uh, charging more ore at a high heat load area may sound very logical, may sound very logical that okay, on the top of the flame front we have to land our burden, but uh, we must have to introspect it to analyze whether it is fully right or it need a correction. But in such situation our coke rate reduction becomes affect our flow drastically. That is overloading a center coke shift the gas away from the wall, and we have to hence always maintain the burden balance. That is, it's the it's the balance of center and wall flow, both keeping in view of our utilization factor, because this balance is basically the heartbeat of a stable furnace operation.